Hello, in the last videos, we discussed what are grid algorithms and many problems. Let's discuss the next one. Here is the question, read it and give it a try. You are given an array of n positive integers. In one operation, you can do the following. Choose an integer x. For all integers I such that a is equal to x, replace those by 0. Find the minimum number of operations to sort the array in non-decreasing order. And the constraints are n up to 1if and the value of a can be less than or equal to n. And for example, if the array is 332, in first operation we can replace all 3's by 0, so the new array will be 002. So the array is sorted in non-decreasing order, so the answer is 1. We have to return the minimum replacement so that final array is sorted. So let's say we have a big array and it is better to replace the elements in the first by zeros or last by zeros. It is surely better to start with the beginning so that we can get a sorted suffix, and therefore we may not need to do any operations here. But if we have to replace the zeros in suffix, then obviously if there are zeros as it is sorted, all the elements before this should also be 0. So just we can try to find the zeros in the prefix so that it can be sorted and we can do minimum number of operations possible. So the simple idea is to find the largest suffix that is sorted so that we can replace the previous values by 0. So as we discussed here, it is better to replace the forward elements, the elements which are starting to 0, so that the whole array will be sorted. So we can find the largest suffix which is sorted and we can try to replace the previous elements by 0. So let's say this is the maximum sorted array which is suffix, and for example this element is 4 and this element is 2. So this is no more sorted. So this is the largest suffix that is sorted. So now we can try to replace all these values by 0 so that we can get a sorted array finally. So this is sorted one and we are trying to make all these values to 0. So let's say we have these two elements present here and here as well. So the blue element which is here is also here. So for example, if the value is 3 here and it is also 3 here and it is 4 here and the same value is 4 here as well. So as in the given operation, if we are trying to replace an element by 0, we have to replace all of its occurrences by 0. So if we are trying to make this 0, then we are going to make this 0 as well and this also 0. So let's say this is sorted array to some set of 2, 3, 4 and 5 and 6. So we are going to replace these both and we are going to make these two 0 as well. But the whole array should be sorted. So we have to make the middle element 0 as well, because these are zeros and there are some occurrences of these in the next indices, and we are also going to make this 0. So obviously the middle elements also should be 0 so that the whole array is sorted. So similarly, these are replaced by zeros, and now we have to make again this set of elements 0 between the before 0 and after 0. And let's say we have again found the elements 2, 2, 3, 4, 4, and let's say we have occurrences of this again in the later part. So here is a 4 and there is a 4 here as well, both 4s. So I have to replace these both by zeros as well. So we can replace these both zeros, and if we try to observe this, it is more like a loop. So we are trying to find in the first we have found the largest suffix that is sorted, and we try to replace the values, and we found that as these both are zeros, middle values also should be 0. So we have to replace this part with zeros as well. But if there is an occurrence, there may be occurrence here as well next to the previous 0. So we have to make every value 0. And even then, what is the guarantee that there is no operation after? And how we are sure that the operations will converge? It is simple to observe here that we found the sorted suffix with the suffix which is sorted. So after this operation, these all are zeros. We have made all these 0 in the beginning, and because of this we made some zeros here, and because of this we made this zeros here, and because of this we made some zeros here. So finally up to all values up to this are 0. But are there any possibility of next operations? Because this is sorted. So let's say this is 4 and this is surely sorted. So the next values are greater than or equal to 4, greater than or equal to the value, or greater than the value. So there is no problem with the values greater than 4. We have to replace only the values with equal to 4 as 0. So if we have many 4s, we have a 4 here and we have some 0, and we are trying to replace every 4 by 0. Then we can try to find the largest 4 and we can replace all of the values till the first 4 as 0. So after this operation, we are guaranteed that there is no need to do operation because the sorted suffix, we have found the sorted suffix. So as it is sorted, we replaced all the occurrences of the previous element by zeros. And from now, there is sorted and there is no possibility that we are going to replace element and we have to replace the other element. So in this way, only by two operations, we are guaranteed that there are no more operations going to be performed to make the array sorted. So if we try to observe, these all are zeros and these all are zeros as well. And the whole array is sorted from this. So we have to replace only the distinct elements in the before set. So any more updates because the rest of array is already sorted. So here is 4 and here is 5 and here is 5 and it is 6. So there is no possibility that we can find a 4 after some sorted array. So we are sure that the rest is the array is sorted and there is no need to do operations in the rest of the array and it is surely sorted. So the next thing is we can use a map to get whether the current element is already changed to 0 or not, or if we observe it is given that ai is equal to less than or equal to n, so it is less than or equal to 1if. So we can simply use a vector of size 1if plus 1, and if the value at index I is 1, it means that we have changed j to 0, and if it is 0, it means it is not changed and it is simply the given array element possibly. And let's check the code. Initially we are inputting the size and vector elements, and now we are trying to make vector v where it is going to store the information whether it is already changed to 0 or not. So we have to find the largest sorted suffix. So how can we do this? We can simply traverse from the ending of the array and we can find the element which is going to break the condition. So if the value is 3 and here it is 2, then this is no more increasing. So we have to make all these up to zeros. So this is the last element that we are making till zeros because this is sorted and the array the condition is broken here. So we have to replace all the elements before equal to 3 as zeros. So we are going to find the largest index where the next indices are sorted. So we are traversing from last, and if a of j is greater than a of j plus 1, it means that it is 3 and the next element is 2. So it is not sorted. So we are finding the last index and we are breaking the loop because this is only sorted suffix and we cannot take any other element in the sorted suffix. So we are breaking the loop. And if last is equal to minus 1, because we are initialized last with minus 1, so even after the loop, if last is minus 1, it means that the whole array is sorted itself. So as the array is itself sorted, the number of operations are 0. So you can just simply return 0. And what if last is equal to not minus 1? So let's say we found the last value, and as we discussed that we are going to make every element till the last index 0. So we are going to use a loop and we are going to replace all the values from 0 to last as zeros. So 0 to last as 0, it means that we are simply replacing v of aj by 1. It means that we are going to change the present value to 1. And why we are not simply incrementing the answer because we are changing to 0? Because we can have many equal elements as well. Because let's say we have 4 2's and we have 1 3 and we have some 1. So the last is this, the last is 3. So we are going to make all these 0. So if we just try to simply count is equal to 1, 2, 3, 4, 5, the answer is not simplified. Because in one operation we can replace all occurrences of it. But here there are 4 2's. So by only simply storing the information about 2, we can check whether the operation is done or not. It is useless to make a count increment if you are trying to possibly traverse the whole prefix. So 0 to last, we are storing it as 1. It means that we have changed it to 0. And from now we discussed that we found the values and we are going to check these occurrences in the later part whether they are existing or not, and if they are existing we are going to replace those by zeros as well and the middle elements by zeros as well. So j is equal to last plus 1 till n, it is a sorted suffix, and if v of aj, it means that we have already made this to 1, so it is present in the prefix and we have made to zeros, so obviously the later elements also should be made 0. So we are finding the last index now where we are going to make operation. Let's say we have 2 to 3 and we have 1 and we have 2 and we have 6. So we are going to make these all part as zeros, these 3 as 0, and we have made 2 to 0. We are going to find the last index till which we are going to make zeros, because now this is the last index to make 0. So we are finding the last index where we have to replace all elements till that as 0. So last is equal to j. It means that we have to update the present element because v of aj, because it is already parked in the mask. in the past, it means that we have to make this 0 as well. So this should be updated. So last is equal to 0. After completion of this loop, last indicates the highest index such that we have to replace all elements from 0 to last as zeros. So now simply int j is equal to 0 and j less than equal to last. We are simply making v of j is equal to 1 again. It means that we are going to make all the elements till last index 0. So after this, we found that no further operations are performed. So simply we can count the number of elements with v of 1 and we can increment the answer. So for auto it of v, if v is equal to 1, it means that we have changed it. So increment the answer. Else, no need, and finally return the answer. In this way, we can return the answer. The minimum number of operations to make array sorted. If you have any doubts, comment below. See you in the next video.